Welcome back. In this new chapter, we will discuss the transformation of graphs of functions. That is to say, suppose graph of function fx is given, then what will be the graph of the function of the shape of the type a fx plus h, that is x is replaced by x plus minus h, and a constant c is plus or minus to the whole function, and a multiplication of the whole function by a. What will be the graph of this function in a general shape? We will discuss each case one by one, uh, so that you may understand it easily. We will break up the graph of the whole transformation into multiple steps, and the first step will be vertical shifts. Right. Suppose a graph of the function is given. Suppose the graph of the function is given, and we add to it or subtract to it a real number c. A real number c greater than 0. Now there is positive real number. Then what will be the graph of fx plus c? That is, fx graph is given. We want to find graph of fx plus c and fx minus c. The rule is, you can easily verify that also. The graph of fx plus c is graph of fx shifted vertically c units upwards, and graph of fx minus c, note c is greater than 0, shifted c units vertically downward. Suppose the graph of a function is as shown. This is the coordinate axis. Suppose the graph of the function is like this, right? Then what will be the graph of this is fx. We want to calculate graph of fx plus 3 and fx minus 3. C is equal to 3, that is, we are taking c is equal to 3. What will be the graph of the function? I am drawing the same graph here for understanding purpose. This is the original graph, right? What our rule says, for fx plus c, the graph will be shifted upwards 3 units. So each point on the graph is shifted 1, 2, 3 units. So the graph becomes like this. This distance is 3 units. This is the graph of fx plus 3. That is, shift the whole graph by 3 units vertically. What is the graph of fx minus 3? Shift the graph 3 units downwards. This is 3. By this we can calculate the graph of fx plus minus c. Fx plus minus c gives vertical shift to the graph. Right, now horizontal shift. What is horizontal shift? Suppose graph of fx is given, then we want to find the graph of fx plus c and fx minus c. In the above example, we have taken whole fx plus c. Here x is replaced by x plus c. Right, if you can compare with this. So the graph of fx plus c is graph of fx shifted left c units. I will give example to explain. And fx minus c, graph of fx shifted right by c units. That is, every point on the graph is shifted right, or every point on the graph is shifted left. Now suppose our graph is like this. Suppose this is our graph. Then what will be the graph of fx plus c? The graph of fx plus c means it will be shifted c units left side. So what will the graph? Graph will become like this. This is fx plus c. This distance is c greater than 0. And what is the graph of fx minus c? The whole graph will be shifted right side c units. So this distance will be c. So likewise, we can plot the graph of functions in which x is replaced by x plus c or fx minus c. Right? Now to remember this, what is the methodology? I have explained vertical and horizontal shifts. Suppose graph is fx plus minus c plus minus k. By this, graph shifts vertical. If plus sign, vertically upward. That is, it follows the sign. Vertically down. Here, if the sign is plus, then left. If the sign is minus, then the graph moves right. That means opposite of sign. This is the method to remember. What will happen if the graph of fx is given if we want to plot the graph of fx plus c and fx minus c. Right? Now we will take it further. Now we have already taken vertical shift and horizontal shift. We have already talked about those graphs. Now I will explain reflections. Reflection about x-axis. Suppose the graph of y is equal to fx is given. Then graph of y is equal to minus fx is reflection of fx along x-axis. First let me explain, then I will give example. Reflection about y-axis. About y-axis. If a graph is y is equal to fx is given, and what is the then graph of f minus x is reflection. Reflection means mirror image of fx along minus x-axis, right? I will give example of reflection about minus x-axis. Suppose this is the graph of a function and is given like this. It is a graph of under root x, and we want to find the reflection of this graph along y-axis. So reflection upon y-axis means graph of this will be graph of under root minus x. Similarly, if you want to take what will be this graph? Reflection along x-axis. This graph will be minus under root x. Here minus is to the whole function. Here minus is just x is replaced by minus x. So this reflection along x-axis, we just replace fx by minus fx. Reflection about along y-axis, we replace x by minus x. In one whole function is replaced negative sign, and in another only x is replaced by minus x. Now I will explain what we call stretch and compression. I will name it S and C. First I will discuss vertical S and C. What will be the formula by which we will getting vertical stretch and compression? Let fx is a function and c is greater than 0, real number. C belongs to real number. And if gx is equal to cfx, c greater than 1, then graph is vertically stretched. Vertically stretched by multiplying each of its y coordinate by c. I will explain, don't worry. And if c is between 0 and 1, then the graph of this cfx will be vertically shrunk or vertically compressed by multiplying each of its y coordinate by c. For understanding this compression and stretching, we have to understand what is the meaning of this. Suppose this is the graph of a function. Suppose this is the graph. This is graph of mod x. Suppose this is the graph. Stretching means every point in the graph is moved upward. Every point in the graph is moved upward. Not same distance. Some distance may be different. Some distance may be different. So the same graph becomes like this. The earlier graph was this. A new graph is this. This is called stretching in the vertical stretching. Then what is the vertical compression? If the new graph is like this, that is every point is moving downward, then it is vertical compression. And this is vertical stretching, and this is original graph. Right. So in vertical stretching, the shape of the graph changes. In compression and suppression, shape of the graph changed. As you can see in the above figure. Suppose this is our original graph, then stretching means the new graph will be like this. This is stretching. And what will the compression? Compression means vertical compression. I'm talking this new graph will be like this. This is stretching, and this one is compression. How it happens? Let's multiply the graph by some real number c. Positive real number. If c is greater than 1, then stretch. C lies between 0 and 1, then compress. Similarly, if we replace now suppose fx becomes f of ax, a positive real number, then for a greater than 1, the new graph is horizontally shrunk, suppressed by dividing each x by a. If a is between 0 and 1, then horizontally stretched by dividing dividing each x coordinate with a. So what we have seen till now, we have seen all the graphs, but I will explain what is horizontal compression. Suppose this is our original graph, then what will be the graph of f c x, c greater than 1? The graph will be horizontally compressed. What will be the graph? Graph will be like this. Each x is divided by a. The height will remain same. And what will the graph of suppose this is our original graph, and what is meant by and c is, this is for c greater than 1. Suppose c less than 1, then what will happen? The graph will be stretched like this. This is a graph of f cx, c between 0 and 1, right? I will deal with one special case so that some confusions are there between the horizontal compression and the vertical compression. It is there. I will remove that confusion, but I will first explain what we have done till now. We have explained graph of x plus minus c. We have explained graph of x plus minus c. We have explained graph of minus fx. We have explained graph of fx. We have explained graph of afx. We have explained graph of xc. These all we have explained. This is vertical shift. This is horizontal shift. This is reflection along x-axis. This is reflection along y-axis. AFX means S and C vertically. S and C means stretch and compress. This is S and C horizontally. Now when I was studying this for making a lecture on YouTube, some confusion came into my mind, and I resolved that confusion. I will explain. Suppose a graph is given, y is equal to mod x. Then what will be the graph of 2x to mod x, and what will be the graph of mod 2x? Sorry. From the above, if you see, the function is multiplied by 2, so it is S and C vertical 2x. Here the x is replaced by multiplied by 2, so it is S and C horizontal, right? But value of these two mod x and mod 2x is same. So what is the meaning? What is how we understand that it is vertically compressed or horizontally compressed, right? I will explain. This confusion came into my mind. Suppose this is the graph of the function of mod x. Mod 2x graph, will be like this. If you see, each point on y have moved upward, so it is vertically stretched. Also, you can see just a visualization. Suppose this is the graph of mod x, and final graph is like this. You can also say each point has been compressed in the horizontal direction. This is also interpretation. So graph is horizontally compressed, same meaning. So whether you take fx, suppose graph is fx given, whether you take 2 mod x or mod 2x, this means horizontally stretched. Vertically stretched, this means horizontally compressed, but our output graph is same, this one. So this was the confusion coming to my mind to make you explain that sometimes vertically stretched means horizontal compressed, but here vertically stretched means horizontal compressed, right? Because the function is just like that. Suppose function is 2x square, suppose function is x square. Now our output function is 4x square. Then it can be written y is equal to 4 into original function, suppose it is gx. It can be written 4 into gx, or it can also be written 4 into g2x. The output will be same, 4x square. Here it is multiplied by a constant, so it is vertical SNC. Here x is multiplied by a constant, so it is horizontal. But the output will be same, but the explanation will be different. You can plot this graph and you can very well verify that both graphs are same. You can also explain from the graph what is the meaning of vertical stretching and compression and horizontal stretching and compression. There is a website called www.dasmos.com. Here you can plot here we can plot graphs of algebraic expression and multiple graphs can also be plotted. Graphs can also be plotted. So use this website to make understanding of this transformation of functions. I am sure that the method I have explained above will be very helpful in all the competitive examinations and understanding of basic mathematics, and it will help you a lot. Just by seeing the graph you are able to find the graph of final function. And what is the use of this shifting and reflecting or taking compression, suppression? What is the use of this? Use of this is simply suppose a graph of a function is given. Suppose we want to plot a graph of this 2 mod x plus 3 plus 4. This is, suppose this is function given, we want to plot a graph of this. Then by making table of graphs and technical evaluating values of x and y, it will become very cumbersome. What we will do, we know the graph of mod x. Graph of mod x is just like that. So whatever we will do, first step, we will make x plus 3. What will be x plus 3? Mod x plus 3. Mod x plus 3, move graph up plus 3 points, right? Then what will the graph of 2 mod x plus 3? Tell me. It will be the stretch vertical, each point by 2, right? Then again at 4, what is the graph of 2 mod x plus 3? We move whole graph left by 4 points. So from the graph of x, first we move this, then to this, then to this, then we can easily plot the graph of this function. This is the purpose of transformation of functions. You can very easily plot the transformation of functions. But please use this website desmos.com for plotting different graphs and checking what is happening actually in the graphs. It will help you a lot in remembering the above different formulas which I have given, whether it will be vertical, horizontal, whether it will be reflection about x-axis, whether it will be reflection about y-axis. It will help you a lot. One thing I have forgotten, odd and even function graphs. Graphs of odd and even function. What is even function? If f minus x is equal to fx, then the function is even, and if f minus x is equal to minus fx, then function is odd. The even function is symmetric about y-axis, that is y-axis will be the mirror image. Suppose we want to plot of even, that will be the left and the y-axis will be acting as a mirror. The left side will be similar to the right side. And odd function, symmetric about origin. That is, suppose a graph is given, first to take graph about mirror image along y-axis, then mirror image along x-axis. So this whole graph is symmetric about origin.